Now, when we've been solving systems of equations, what we've been looking for is the point where the two lines intersect. But here we're going to be solving systems of linear inequalities. And what that means is we're going to be graphing a linear inequality and doing some shading. We're going to do that a couple of times on the same graph, and what we're looking for is where the two shaded regions overlap. Here's how we do that. Step A. Remember, we're actually going to be graphing the line. Now, in an inequality, the line itself will either be a dotted line or a solid line, depending on if it's less than or equal to, greater than or equal to, just less than, or just greater than. We'll talk about that in just a minute. Remember, we have to shade either, most of the time, it'll be either above the line or below the line. We'll talk about that. And then the answer is where do the two shaded regions overlap? That's what we're looking for. And let's talk about how we do that. Number one, we have y is less than negative 2x plus 4. If I were going to be graphing this line, y-intercept being positive 4, and the slope being negative 2, I'm going to go down 2 and right 1, and I'm going to draw a dotted line or a solid line. Well, because it just says less than, it will be a dotted line. So there's the dotted line for y is less than negative 2x plus 4. And because it says less than, I need to shade underneath the line. So if you put your pencil on the line and either go up from the line or down from the line, we're going to shade the area of the graph that is below the line. So y is less than negative 2x plus 4 looks like this. All right, now we need to graph y is greater than or equal to 3x minus 4. And to do that, I'm going to be starting at negative 4 on the y-axis. I'm going to rise 3 and run 1. And I'm going to draw a dotted line or a solid line. Well, whenever you have a solid line here, I want a solid line on the graph. So this is going to be a solid line. And now I'm going to shade, because it says greater than, everything above this line gets shaded. So everything above the solid line gets shaded in blue. And if you'll notice, this region here, well, blue and yellow are supposed to make green. I suppose that kind of looks like green, doesn't it? Anything in any point in this shaded area out here will satisfy both inequalities. Notice over in this area there's no shading. Here it's just blue. Here it's just yellow. But over here, this is where my answers are. Any point in that shaded area will satisfy both inequalities. Let's go on and do number 2. Now, in these equations, we don't have the y by itself. In other words, these are not in slope-intercept form. So if I take 2x plus y is greater than or equal to 1 and subtract 2x from both sides, I'll get y is greater than or equal to negative 2x plus 1. So how would I graph that? Well, I need to start at positive 1, and I'm going to go down 2 and right 1. And will this be a solid line or a dotted line? It is a dotted line. Excuse me, a solid line. And now, because it says greater than, I'm going to shade everything above this line. And it'll look like that. Now let's take the other line. X minus y is greater than negative 2. I'm going to subtract x from both sides. Now think about what you have here. This is the opposite of y. Negative y is greater than negative x minus 2. And I have to divide by -1, right, to get that y by itself. Now, what happens to the inequality sign when that happens? It reverses, and I get x plus 2. So I'm going to be starting at +2 and rise 1, run 1. This is just less than, so it'll be a dotted line. And now I'm going to shade everything below this line. And it should look something like this. So anything in this area out here, bounded by this solid line and this dotted line, any combination of points in that area would satisfy both of these inequalities. Remember what the line x is less than or equal to 1 looks like? This is a special situation. You're going to have to remember this one, that x, if you were to graph x equals 1, that is a vertical line at where x is equal to 1. So I go to x is equal to 1, I'm going to make a vertical line. Is it going to be a solid line or a dotted line? It'll be solid, and this is the only exception to graphing above or below. In this case, I'm going to have to either graph to the left or to the right. Where is everything less than this line? If I were to graph out here, shade out here. And then y is is greater than -2. Well, this is a horizontal line, and it's at where y is equal to -2. So I draw a horizontal line, and it'll be dotted. And because it says greater than, I want to shade above. So I'm going to take everything and shade above this line. And again, if you'll notice that out here, there's no shading. Here it's only blue. Here it's only red. Where is it red and blue? Up in the left-hand corner here. So that's our answer there. Number 4. Write this in each of these in slope-intercept form. X plus y is greater than or equal to 5. Subtracting x from both sides, greater than or equal to -x plus 5. Well, that means I'm going to be starting at +5 on the y-axis, down 1, right 1. And dotted or solid, it will be a solid line. It says greater than, so I'm going to need to shade above the line. So I have all that. My other line, x plus y is less than or equal to 1. Subtracting x from both sides, you get y is less than or equal to -x plus 1. I start at +1, and I go down 1, right 1. And is this a solid line or dotted line? Again, it is solid. I'm going to be shading everything below the line. Now, where do these two overlap? Well, they don't. So in that case, there is no solution, because they don't overlap at all, do they? Let's look at number 5. X plus y is less than 4. When I subtract x from both sides, I get y is less than -x plus 4. So I start at +4 on the y-axis, down 1, right 1. Kind of like the other one that we just did. And it'll be a dotted line. And because it says less than, I'm going to shade everything below the line. Then I'm going to do x plus y is greater than -1. Subtracting x from both sides, y is greater than -x minus 1. And I start at -1, down 1, right 1. Is this going to be a dotted line or a solid line? Again, it is dotted. And because it says greater than, I'm going to shade everything above. Now again, these two lines are parallel like they were in number in number 4, but in this case, the shading is overlapping. See, over here I have only red. Up here I have only blue, but in between the two lines is where they overlap, and that's where it's red and blue. So any point in that combination, in between those two lines, would be your solution here. Any point, and the coordinates of any point in that shaded area would satisfy both of those inequalities. So let's take a little bit of a review, see if we make sure that we understand exactly what's going on. We're going to start off by graphing the line. Now, it'll be a solid line if it says less than or equal to or greater than or equal to. It will, we will shade above if it says greater than, and we will shade below if it says less than. Your answer is going to be where the two shaded areas overlap. And if they don't overlap like they did in number 4, there's no solution. And that's just about it. Good luck on your assignment. And if you have any questions, let's talk about it then. See ya.